Command and query responsibility segregation, or what they call CQRS. Hi guys, today we're going to learn CQRS. Based from what I read, let, let's discuss why we use this CQRS pattern. Based from this reference, techtarget.com, we basically use CQRS because we need uh, we need to basically simplify the query process and hide the complex business logic. Some reference also saying that we use this design pattern to for us to independently scale the read and write operations. Yeah. Um, some other reference also said that we use this to for us to be able to query data from multiple microservices. Yeah. So let me show you the diagram I saw in this one of these web references. As you can see in the diagram, this is the client. Basically, there is a separation between the command and query operations. When we say command, this could be insert, delete, or update operations in our database. Then for query, obviously this is the select star from our DB. Okay. So yeah, there is that separation here. As you can see, the when the request, basically the command will basically write the data to a separate DB. So basically there are two service here, which is separated. One service has its own database for writing purpose only, and the other database, the other operation got its database for read only DB. Okay. Why we separate them? Because we want them to scale independently, right? I'll give you some scenario why we need that. For example, in a social media, there are based on the survey, the 70% of the transactions there are more on searching, and only 30% is more on writing operations like posting. Yeah. So in order to resolve the issue of scaling independently, they introduce this CQRS pattern. Okay. So as you can see in this diagram, this is the command. There is a command handler and a write model and write DB. Okay. There's basically DB for command and separate DB for query. And these two database are we need to synchronize them. And how to synchronize them? We use event or messaging broker. Yeah, basically like Kafka or RabbitMQ. Why we have to do that? Because if we don't do that, we won't get data in our query DB. So we have to synchronize these two databases for us to be able to execute our query successfully. Okay. So let me show that in our SpringBoot implementation. So here, as you can see, I created two microservice. Let me show it to you side by side. So the first service I created is for, show it to you. Yeah. So I have here service for creating. I create an endpoint to create a record and insert it to our DB. Then send message to our Kafka to synchronize it to the other database. Then I have also here another microservice to query the DB. It has listener. As you can see in our command microservice, I send a message whenever I insert a record in a database. I also send message to Kafka with this topic, customer topic, to send whatever I insert in the DB, right? So then in the other microservices, I listen to the same topic, which is customer topic here, as you can see. Then I consume the message, which is this object, customer object. Then I insert to its database. Remember, we have separate DB for this one, for command microservice, and for query microservice. Let me show you that in our DB. So I have a sample database here, test DB. So I create two schema, one for command and other for query. So right now I think it has record. Okay, let me delete this. So it's easy to test. Okay. So now it's empty. So we have we're supposed to have two database, right? One database for command microservice and another service for query microservice. But in this demo, since this is just a demo, I did not create a separate DB. Since it's just a demo, I just created a schema, right? So just imagine this is a separate DB and separate DB for command and separate DB for query. Okay. Anyway, the important is they have separate storage. Okay. So one for command DB and for query DB. Okay. So now the customer table is empty. Okay. So let's test I'll show it to you. First, let's run our command microservice. So we run it in using port 8181. Okay. Let's run it. Same time, we also run our query microservice. This one is using port 8080. All right. So basically, as you can see, it's more complex, right? But in basically, as I said earlier, the goal of this design pattern is for scaling, right? We want the read and write operations to scale independently. That's why we separate the command and the command and the query operations. Okay. and then we have to synchronize their database, because if we don't do that, then we cannot query the data. That's why here, after we create the record, we send the message to our broker Kafka, so that by sending this, we send a signal to our other microservice who subscribe to this topic, for so that this microservice can update its database. Okay, so whenever we insert records to this whenever we insert records to the database of this microservice, the command microservice, we also at the same time we also update the database of this query microservice. So in short, we synchronize them, right? So whatever we write, we can read the same data. But actually, in real world, they don't have to have exactly the same table schema. In real world, we can insert, for example, here in command microservice, we can just write all the data that we required in the process. Then in our query microservice, we can only persist or save whatever is required in the UI for displaying. So yeah, they don't have to be exactly the same, but for this demo, I just copy and paste it for quick how you call it, so that we can quickly demonstrate it. Okay, but then again, it's not necessary to have exactly the same DB or structure of the database. The important is for the command microservice, we save whatever is necessary in the process, internal process. Then for our query, we only save what is necessary for our displaying, UI displaying. Okay, so I already started both microservice, so they are up and running already. So I think we can test now. Now our DB are empty. For our command DB is empty, query DB is empty also. Okay, so first let's run the command for this one. Let's say the customer ID is 100, name is Aga, fund, let's say the fund is 1000. Let's execute it. See, okay, customer has been created. So this is the record we inserted in our DB. As you can see in our database a while ago, both are them is empty, right? So in command, of course, we expect one record, right? Let me refresh this. So this is the one we inserted. Here in our query schema, or let's say DB, that's it, because by right it's supposed to be separate DB, right? But for demo purpose, I instead of DB I use schema, right? But bottom line here is they have separate storage for its microservice. So we expect the same data, right? Because we synchronize them. So let's refresh this one. All right. So they are synchronized. Now, if we query this, of course, we can get the data, right? So in our, let me query this. HTTP localhost Remember, we use 8080 for the query, right? Query ID is equal to 100. So we expect same record for the query. Right, this is the record. Same as what we insert, right? So this is the one we inserted in our DB, and this is the one we query from our query DB or schema. Okay, same. But then again, as I said, this is just a demo. In real world, they don't have to be the same, right? Maybe in our command microservice, they could have as many, maybe 100 fields, but then again in our query, maybe we only need to display 50 or 25 fields. So yeah, they don't need to have exact fields or structure. And same for DB, they don't need to have exactly the same DB. The command can have a RDBMS, then the query DB can use a non-SQL DB. It's basically based on it depends on your requirement. All right. So I think that's all, guys. Thank you very much for watching this video. I hope you learned something useful today. I'll see you again next time. Bye bye.